Your homework tonight has two proofs that follow a very similar pattern to the one we see here in example 3. In this particular problem, we're asked to prove that angle B right here is congruent to angle F, and we're told that each of the two figures are parallelograms. One of the things that we know about parallelograms is that the opposite angles have to be congruent. So for example, angle B would have to be equal to angle D. Also, if we look at the smaller parallelogram, we would know that angle F has to be congruent to the other side of angle D. In addition, we know that these two angles here in the middle have to be equal to each other because they're vertical angles. So we're going to start with those three lines, and then we're going to use the transitive property to prove that angle B must be congruent to angle F. So let's begin. Let's start off by saying that angle B is congruent to angle CDA. Now, I'm using CDA to refer to this angle right here, from C to D to A. And I'm saying that it has to be congruent to angle B because they're opposite angles of a parallelogram. So I'll write opposite angles of a parallelogram are congruent. There we go. Next, we'll go into the next parallelogram, and we'll say that angle EDG, which is this one right here, has to be congruent to angle F for the same reason. So we'll say angle EDG is congruent to angle F, and it's the same reason. The opposite angles of a parallelogram are congruent. Next, we'll take a look at the two angles in the middle. They both kind of look like they're angle D. This one here on the left and this one here on the right. We'll call this one CDA and the one on the right EDG. And we'll say here that angle CDA is congruent to angle EDG because they are vertical angles. Now we want to build a bridge from B all the way to F. And the way we're going to do that is by saying, well, B is congruent to D. We've already said that. D is congruent to the other side of D. And then finally, D is congruent to F because of the opposite sides of the parallelogram. And so now we can end our proof by saying that angle B is congruent to angle F by the transitive property. And we have proven what we've been asked to prove. Another way to look at this, if we're getting a little lost with the labels, is we can call this angle 1, angle 2, angle 3, and angle 4. I know that 1 is congruent to 2 because they're the opposite angles of a parallelogram. I know 2 is equal to 3 because they're vertical angles. And I know 3 is equal to 4 because they're the opposite angles of a parallelogram. Therefore, I'm allowed to jump from 1 all the way to 4 by the transitive property.